Ma'am, when we are booking ticket for a particular seat, maybe, or just for tickets as well, ma'am. The person who is first in the queue gets the ticket first.
All right. So who is seeking for the ticket for the first mummy logged in first? He or she will get. Okay.
Ma'am, biscuit packet.
Biscuit packet. Taking biscuits from the packet.
Yeah.
No, that is stack. Swapnil, it's good example, but stack. It's a stack.
Okay.
You relate with the morning topic. Is it applicable for that?
Yeah.
You take a packet of biscuit. There were some 10 biscuits.
Yeah.
Others, what are you doing? I'm asking first in, first out. You think in and around electronic devices you have the applications which you are using. Nowhere we are dealing with single data. All deals with collection.
Climbing ladder.
Climbing the ladder. No. That is also stack. Ladder concept, Vaishnavi, I'll come to you. Ladder concept, let's say there is a ladder, or you take your home steps. That is a stack. Am I right, guys? Please debate me if I'm wrong. The ladder and the steps falls under stack as per my knowledge.
Yeah.
Because let's say,
ma'am, it depends on how the person is using the ladder.
How they are using the ladder.
No, ma'am. If the motive is to climb up and not come down, it's a queue. And if the motive is to climb up and then climb back down, then it's a stack.
Sudeep, come on. Let's assume there is a ladder and you want to climb to top floor. There were some 12 steps. In which order we will go? Let's assume bottom. From bottom, we make it as count 1, 2, 3, 4, 5, 12. So we started from first step, second step, third step till 12. When you are getting down, you will again think. You will again start from 12. 12, 11, 10, 9. Am I making it? It's a stack, but it's good example. Both biscuit packet and ladder. Debate me if you found some other logic.
Ma'am, toll plaza. When vehicles are coming first and taking ticket.
Correct. Very good example. Toll plaza. I'll give you one scenario. Meanwhile, if you think, let's assume we all working in an organization and all of us are having a laptop, and we have the option of all our laptops are connected with printer, and there is only one centralized printer. For example, I am giving the print, followed with Joel is giving, followed with Kudus is giving, followed with Ramya is giving. But unfortunately, printer device is not turned on. So after some time, we four realized that the printer is not turned on. So we are going and turn on the printer. Whose print will come for the first time? Whose print will come first?
Yours.
The one who gave print. So that is a good example for queue. Think about it. So your printer will queue all the documents. It's applicable for one computer and one printer also. Let's say my machine is connected with the printer. So I gave 3 prints. I gave this PowerPoint, I gave one Word document, I gave one PDF. I realized that printer is not turned on. Even though it is turned on or not turned on, when you the printer will print in such the way, whichever the document I gave print first. So that will be the first output. First print will be the first out. And then second, and then third. Any other example?
Ink, ma'am.
What, Madhu?
Ink.
Elaborate.
Ink pen. First,
Pen.
Refill the pen with the ink. So whatever the first we have filled, it will get used in that way.
This pen is having refill.
That refill will fill the ink, right? Like it is.
How many refills will be there for pen? But I relate. Day before yesterday, my daughter bought that what pencil? Oh, there is one pencil, no? Oh my god.
Lead pencil.
Huh?
Lead
That-
pencil.
Uh,
That we use
so
lead.
there were some 6 or 7 nib with that pencil. So we can put one it's over. You can put in the bottom. I don't remember the exact name we used to use. But pen, I don't think. One pen is connected with, nib is connected with one ink set. All right. But I'm relating that for Q. If you have some 4 refillers, one after another or shuffled order.
Say each pen we refill the pen with the ink.
We're dealing with ink, ma'am, not refill.
Not
In
re-
fact,
not
inside the refill there is ink, na. So what will
Ink,
come first?
ink. How can we relate with Q? Because it's not a single substance. Anyway, think about it. Think, relate it. If I'm not wrong, it's okay.
If nib is filled with different colored ink,
Are you continuing the same example, Praveen?
yes,
It's not striking in my mind to relate with Q. That's okay. If you have related, that's fine. Okay. So we will resolve all these problems by storing the request in such the way they retrieved in the order of their arrival. Data structure called Q stores and retrieves the data of its arrival. Q is also called as first in, first out. I would like to compare stack and queue as of now. So stack follows last in, first out. Queue follows first in, first out. And one more point I want to recap is regarding top position. In stack, I can push an element and I can pop the element at one end. And the end is called as top end. We have only one end where I will insert an element, where I will remove the element, and the end is called as top. But Q is not like that. In Q, we have 2 ends. One end is called as rear end, the other end is called as front end. Q is a list of elements in which elements are inserted from one end. Inserted happens at rear end. Deletion will happen from front end. So you take this list. Tell me what element is inserted for the first time when the queue is empty.
B.
B.
All of you agree? So we have inserted B first, and then we have inserted A, and then E, and then C, and then D. For example, if I want to insert J, so I will be inserting J in rear position. So this is the order. B will be connected with A, C, E, C, D. If I have sixth element will be inserted in rear position. If I want to delete, which item will be deleted first?
B.
B.
Undoubtedly, it is B. So B will be deleted first. No. 1 second. Yeah. So B is the first element we have inserted, and B is the first element to be removed. Let us have a detailed discussion on queue working algorithm and 2 process. One is insertion, 3 process: insertion, deletion, and traversal. I would like to repeat one another point. Always we will add items in rear, and we will remove the items in front. So these are the two operations. Before. So if I want to insert an item, we will insert in rear mode. Initially, rear will be pointing out to D. So rear next will be the new node, and after connection, your new node will be the rear node. If you want to add F after D, so item is inserted at rear node, F will be inserted D, and you have to make F as a rear node. All right, let's go with an empty queue. Listen carefully, come along with me. So imagine like, okay, I'll go for the same kind of a diagram. So let's assume queue. So guys, it's an empty queue. Shall we start? So now tell me, where will be my front node and where will be the rear node will be there in an empty queue?
Front will be at the bottom.
I don't have any record in my queue. It's an empty queue. What is the position of front and rear? Hitesh, no.
Same first one, ma'am.
We will go to first item insertion. I'm talking about empty queue. When we are in an empty queue, both front and rear will be null. All of you agree with me?
Yes, ma'am.
Yes, ma'am.
So now let's assume you want to insert. Let me take 701. I want to insert the value 701. What I will do? I will insert. What is the first step? Let's try an algorithm.
Allocate memory.
Step 1, without any doubt, when you are in insertion, allocate memory. So let it be new node and assign value.
Value.
Okay. So let's assume I want to insert the value 701. Step number 1, I want to allocate a memory. So when I allocate a memory, imagine like some memory will be created. Let's assume 2005. So a 2005 memory will be allocated where I am storing, is it confusing 701? Oh, yeah, let's go some other value. I will insert variables, string variables. So let's assume I am inserting Harsh. So I need to allocate a memory. So we are allocating a memory, imagine like 2005, and we are storing Harsh. Is that okay? Okay, third step. So chances are there if my queue is an empty one. Else it is not empty. So anyway, for our first case, queue is empty. So think and tell me, if the queue is empty, I'm inserting the first item, what will be the position of front and rear?
Thoughts will be rear end.
Both same, ma'am.
Both are side.
Very good. Very good. So both front and rear pointing to the same node because it's a first item. Shall I continue next? Oh yeah, let me complete the algorithm. If the queue is empty, make friend as new node. Make rear as new node. Shall I continue? Is that clear so far?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Let's assume I am inserting Shubha. I want to insert the value Shubha. For your kind information, our queue is not empty and our front and rear is pointing to Harsh. Okay, these two steps remain same. So I'll be already having 2005 memory. And I'm having Harsh. So when I want to create, when I want to insert new item, create a memory, imagine like 2088 memory has been created and I have Shubham. So now tell me, it is not if case, it will go to else case. My queue is not empty. So my queue is not empty. If empty, else not empty. It will go to not empty case. What I need to do? I would like to rewind to here. Always item insertion will happen at rear end. Do I want to do anything with the front when I am doing insertion?
No, ma'am.
Yeah. So I would like to highlight this point. When you are doing an insertion, you should concern only on rear end in queue. No need to worry on this front node. When you are working on deletion operation, at that time, you will be concerned on front. All right. So always when at the time of insertion, you need to reposition your rear node. So now, yeah, my list is not, my queue is not empty. So it will go to else block. So what we need to do for your information, front and rear, both are pointing to Harsh. And one more thing, linked list relationship needs to be placed.
New node dot next equal to rear.
So the next step is algorithm. If it is not empty, you will be having new node. This new node dot next will be the address of rear node. So what is the rear node? Rear node is 2005. 2005 will be referenced in my 2088. Very important. What is the last step? Think about it. Think about it. When earlier I have only Harsh. So now I inserted Shubham. So what I need to do with rear? No need to think about front.
Rear is equal to new node.
Very good, very good. So now you want to make rear as your new node which you have created. So for your information, fourth step, this relationship happens. Fifth step, Shubham will become rear node and Harsh remains front node. Take time, analyze the same. I'll repeat the same process. Let's assume I am gonna to insert Vivek. So you help me to completing algorithm. This is as usual. The first two steps remain same. So you need to allocate a memory. I assume like I am creating 2051 memory I am creating. In that memory, I am storing my data, Vivek, and tell me. It will not go to if block. It will go to else. What I need to do in else. And for your information, front is pointing to Harsh, rear is pointing to Shubham. Any change we need to do for front? No.
No, ma'am.
No, ma'am.
Only thing is we need to swap rear, and by the way, you need to establish relation between Vivek and Shubham. What is my new node? Vivek. Vivek dot next will be the current rear, and we want to make the rear node as new node. So by the way, what is a new node? Vivek. What is a rear node? Which was Subham. So I need to connect memory address of Subham in Vivek, and I want to swap my rear node. That's all. Take time, analyze. I'm copy pasting the same. I'll insert one more record. That's all. I'll proceed with delete and we'll have a program. It's a simple one.
Ma'am, your screen unshared.
Hello everyone. Just wait for 5 minutes. She is joining back. She has got some update issue in her machine. Okay.
No issue, sir. No issue.
Yeah.
Sure,
please wait
sir.
for
Yes,
5
sir.
minutes.
Okay.
She is joining back.
Hello, sir.
Yeah. Tell me.
We have been back from wave 27.
Okay, Siddharth. So from today only you have came back to this sprint.
No,
And
Yes, sir.
wave. Okay. So now 40. Now how many learners are there in this batch?
We are two.
Link list.
Okay.
We were in half of the